Welcome to AmeenAcademy.com. In physics, let us discuss about rotational motion. Now let us discuss about further dynamics of rotational motion about a fixed axis. Look at this figure. Here, this is a fixed axis in which a circular disc is fixed rigidly. Then the disc is rotated with respect to the axis of rotation. Rotational motion can be defined as the motion of an object around a circular path in a fixed orbit. The dynamics for rotational motion are completely analogous to linear or translational dynamics. Many of the equations for mechanics of rotational objects are similar to the motion equation for linear motion. In rotational motion, only rigid bodies are considered. A rigid body is an object with a mass that holds a rigid shape. Here, this is a rigid body, that is, a disc is a rigid body considered, and it's rotated. Rotational motion about a fixed axis. The figure above shows a rotating body that has a point with zero velocity about which the object undergoes rotational motion. That means this disc is rotating, but this axis is not moving in translational. That means this axis is in a fixed point here. That is, this axis is not moving linearly or round. Now, rotational motion, some examples you'll see. Ceiling fan rotation of the minute hand and hour hand in our watch, and the opening and closing of the door are some of the examples of rotation about a fixed point. Here, ceiling fan is hanging from the ceiling, that is an axis, that rod is an axis, and the fan is rotating about it. Rotation, the examples for rotation about an axis of rotation. Here, rotation about an axis of rotation includes translational as well as rotational motion. That means that the solid body is rotating about an axis, and axis also move around. That means it's some translational and circular motion. Axis also moving. The best example of rotation about an axis of rotation is pushing a ball from an inclined plane. Suppose you push a ball from the inclined plane. What happened to that ball? The ball moves towards the bottom as well as it's rotates. The ball reaches the bottom of the inclined plane through the translational motion, while the motion of the ball is happening as it is rotating about its axis, which is a rotational motion. Another example of rotational about an axis of rotation is the Earth's motion. Here, the Earth rotates about its own axis every day, and is also rotates around the Sun once every year. This is a classic example of translational motion as well as rotational motion. That means our Earth is rotate around the Sun as well as it revolves itself. Rotation motion dynamics. Here, in rotational motion dynamics, some important topics are there. Here, and that moment of inertia. What is moment of inertia? The moment of inertia measures the object's resistance to the change in rotation. That means while rotating, some difficulties it shows to stop its rotation. That's called its inertia. Suppose heavy body rotating, it is harder to stop it than a smaller body rotate. That means for heavier vehicle, we need heavier brakes to stop it than a small vehicle. The moment of inertia is symbolized as I and is measured in kilogram meter square. Look at here, this unit is kg meter square. The moment of inertia is given by the following equation. Here, I equal mr square, where m is the particle's mass and r is the distance from the axis of rotation. That is, the distance of axis rotation is more, the moment of inertia also more. If mass is more, moment of inertia also more. The moment of inertia depends on the particle's mass. The larger mass, the greater the moment of inertia. Following is the table for the moment of inertia for symmetric bodies. That means we will have this in later also. The torque is the twisting effect of the force applied to a rotating object which is at a position R from its axis of rotation. Mathematically, this relationship is represented as follows. Here, torque is radius into cross product as multiplied with the force vector. Radius vector cross product into force vector. Next, angular momentum. Angular momentum L measures the difficulty of bringing a rotating object to rest, which is given by the following equation. L equals sigma R vector cross P vector. Moment. Here, look at this table. The table below lists the quantities associated with the linear motion and its analogous to its rotational motion. Here, we are having the difference between linear motion and rotational motion. Here, first, displacement is x, and rotational motion also we like theta we put. It's a theta. Now velocity v, here velocity is dx by dt, and acceleration is a dv by dt. Here alpha is angular acceleration, d omega by dt. Mass is m, here mass is I, here moment of inertia here. Force F equal to ma, here torque equal to I alpha. Moment of inertia into rotational acceleration. Work dw equal to force into distance, and work equal to torque into d theta. Kinetic energy is K equal to mass into velocity, mass into mv square here. Kinetic energy is mv square. Here kinetic energy is I omega in rotational motion. Power equal to Fv, power equal to torque into omega, or torque into omega is power in rotational motion. Linear motion equal to linear momentum P equal to mv, P equal to momentum, linear momentum equal to P m I omega square will not be there. P equal to mv and I equal to I omega, L equal to I omega. Now let us see one more time in simple manner what is moment of inertia. The moment of inertia measures the object's resistance to the change in its rotation. That means the moment of inertia tells about how much force we need to resisting force that body gives to us to stop itself or reduce its speed. What is torque? Torque is the twisting effect of the force applied to a rotating object which is at a position R from its axis of rotation. That means we are using a spanner to tighten or loosen the nut and bolt. We need to give a torque at the end of the tool. A torque and moment of inertia is similar. Is it similar? No, the torque and moment of inertia are not similar, since torque is dependent on the magnitude and direction of the force and on the application point, whereas the moment of inertia is dependent on the mass and the axis of rotation. Define tangential acceleration. Tangential acceleration AT is defined as the linear acceleration of a rotating object such that the linear acceleration is perpendicular to the radial acceleration. The SI unit of tangential acceleration is meter per second square. Now, what is the difference between angular acceleration and tangential acceleration? Angular acceleration and tangential acceleration are most of the time considered to be similar, but they are not. Angular acceleration is the change in an object's angular velocity over time. Angular velocity over time is angular acceleration. In contrast, the tangential acceleration is defined as the change in the linear velocity of an object over time. What is the difference between translational and rotational motion? Just now we talked about the velocity of an object is constant when the object is moving under a translational motion. In contrast, in the angular velocity of an object varies when the object is moving under the rotational motion. That means the velocity of an object is constant when the object is moving under the translational motion. In contrast, that angular velocity of an object varies when the object moving under a rotational motion. In translational motion, mass of an object is considered, whereas in rotational motion, moment of inertia of an object is considered. For translational motion, we need mass to calculate, and whereas in rotational motion, we need moment of inertia of the body to calculate rotational motion. So far we have discussed about rotational motion and its definition, as well as in difference between rotational and translational motions also. We have done. Please subscribe our YouTube channel.